Welcome to the Unit 6 review on quadratics. Remember, you could pause the video at any time if you need to either rewind or take time to write stuff down. I'm going to be going through this worksheet. You could have either downloaded it from your teacher or just followed along and done the work off to the side by looking at it. Either way, it will work. I'm going to pause it a few times and put the answers up there, as well as walk you through some things. Okay, for each of these steps above, 1, 2, 3, 4, 5, in question number 1, explain how the step was done and include the names of any properties that were utilized. I'm going to go ahead and put the answers up there, and then I'll kind of talk through it. Okay, from step 1 to step 2, we added 15 to both sides, and by adding that 15 to both sides, I was able to come up with the second one. Then we went ahead and factored it to x minus 5 times x minus 3, set them both equal to 0, then adding 5 to both sides and adding 3 to both sides will get us x equals 5 and x equals 3. Moving up from here, given the parent function, which is this, and again the parent function is y equals x squared. You can see it right here. Might be a little bit small. But given the parent function, state the transformations that occur. And sorry, this was supposed to be over here, but it kind of got jumbled. So we'll do A first, and we'll do it in blue. This first one is going to go left 2. Remember, anything on the inside in the vertex form is going the opposite direction. So that's going to go left 2 from the parent function, and then we're going to go down 3. And that is A. The B, we look inside, we're going to go to the right 4, remember the opposite, and up 7. So for B, we're going to go to the right 4, and then up 7. And then our last one, if you could see, we have a negative A that's going to flip it upside down, so it's going to be flipped upside down. It's going to face, or it's going to open downward, and we are also going to go up 4. Number 3, given the graph of the parent function y equals x squared above, sketch each of the following graphs. Again, we have A, B, C, and this C is finished out over here, and then we have D, so we'll do those in different colors as well. The first one here, x squared plus 2, is just going to move it up 2 units. We have nothing inside with the x, no h value, so our k is going to move it up. Our b, we've got x squared minus 4. That's going to be our red one here. Again, all this one's going to do is go down 4. 1, 2, 3, 4. And passes through there. C, our y equals x plus 5 squared. Remember, it's anything inside. Our h value is going to be the opposite. So our C, our blue, we're going to go to left 5. 1, 2, 3, 4, 5. And again, it's just like the parent function, just move 5 to the left. And then our last one, D, we've got x minus 7 squared. This is going to go to the right 7. 1, 2, 3, 4, 5, 6, 7. And again, touching right there and going up. All right, moving on to page 2. Again, we have 2 parabolas, and we're going to find the following information. Again, our vertex is going to be right down here. Our y-intercept is going to be right here. Our x-intercepts are going to be here. So let's get those down first. -1, -4. It's a minimum. X-intercepts. Go blue. -3, 0. y-intercept is 0, -3. Our domain is -infinity to +infinity, and our range is -4, and it's included. Notice the bracket, because it can be included. That point is available, and it goes all the way to infinity here. And again, let's find the vertex. Vertex is right here. It's a little bit hard to see. It's right there. We've got our y-intercept, which is our red dot right here. And then we've got our x-intercepts, our blue dots, which are right here and right here. And we've got our axis of symmetry. Again, it's going to be that line going down right there. And if you notice here, this is 1, 2.5 here, and it looks like it's about 2 1/4 up that way. So we'll just use the 2 1/4. All right, and again, 2.5 over and about 2 1/4 up, so we listed that as our vertex. Again, it's facing downward, so we have a maximum. You just have to write down the 2 points that we put in blue for the x-intercepts, the y-intercepts, the red. The axis of symmetry, again, is the line that equals the x value of the vertex, and the domains are the same, but this time, this one has a maximum, so it can't go any farther than 2.25. So now, again, in our listing of our range, we go from the lowest possible to the highest. Again, lowest possible to highest. It can't go below -4, and it includes it. This can't go above 2.25, and it includes it as well. All right, solve the following quadratic equations using any method. If I notice this one right here, I'm looking for factors of 12. Again, it's a positive C. Factors of 12 that add to 7. Well, if I think about that, 3 times 4 is 12, and 3 plus 4 is 7. So I think I'm going to factor this one out instead of using the quadratic formula or anything else. Again, factoring them out, then I set each equation equal to 0. X plus 3 equals 0. X plus 4 equals 0 using the zero product property. Subtracting 3 from both sides, subtracting 4 from both sides, I end up with x equals a -3 or x equals a -4. This one, give you a little hint, it's not going to factor very well. I'm going to go ahead and use the quadratic formula on this one. Again, the first step is just direct substitution. I put my formula up here. I've identified my A, my B, and my C, and directly substituted them in before going any further. So make sure this matches before you go any further, and then go ahead and start doing the math. And the next step, -7 is a +7. -7 squared is 49. And 4 times 6 is 24 times 2 is 48. So subtract 48. And then 2 times 6 is 12. Simplifying it to 7 plus or minus. 49 minus 48 is 1 and 12. And then we split it into our two equations. Again, the square root of 1 is 1. So we got 7 minus 1 divided by 12. Or 7 plus 1 divided by 12. And there we have it. 7 minus 1 is 6 divided by 12 is 1/2. 7 plus 1 is 8. 8 divided by 12 is 2/3. Okay, given the function y equals x squared minus 2x minus 15, find the y-intercept of the function, find the x-intercept of the function, and find the vertex. Again, the y-intercept is going to be this number right here. It's going to be the c value. So we already know the y-intercept is 0, negative 15. When it's in standard form, the c value right here is going to be the y-intercept. The x-intercepts, I'm going to look and see if this factors. Do I have two factors of 15? Remember, I've got a negative c, so I've got to find the difference of 2. Well, the first things that pop to mind, 1 and 15. Now that 15 minus 1 is 14. I've got 5 and 3, and 5 minus 3 is 2, so I know those are my two factors. And you can use a quadratic formula to solve that, or you can graph it to solve it, but it's easy. It's just a factor because I know I've got a 3 times 15. So I know those are my two factors, and I know it's negative, so I know they're going to be opposite signs. I've got the b value is a negative 2, so my one furthest from 0, my larger value, or the one furthest from 0 is going to take the negative sign. And then I set them both equal to 0. X plus 3 equals 0, or x minus 5 equals 0. Subtract 3 from both sides, and I get x equals a negative 3, or x equals a positive 5. So my x-intercepts of this function are 5, 0, and negative 3, 0. Now we move on to the vertex of the function. Again, we need to identify our a and our b and our c. Okay, our a is 1, our b is a negative 2, and our c value is 15. Now we only need the c value because we need to find the y-intercept of the function. And again, our formula for putting it in vertex form, our h is going to be equal to a negative b over 2a. So we have our negative, again, direct substitution, negative 2 over 2 times 1. And negative 2 is going to give us a positive 2, and 2 times 1 is 2, so our h value is going to equal 1. That's going to be our x value, which is our h value. Our k, we need to substitute back in to the original equation, so we have x squared, which is going to be our x is our 1, so we have x squared minus 2 times x minus 15 equals okay, and we have 1 squared is going to give us 1. Negative 2 times 1 is a negative 2, and then minus 15. So we have 1 plus 2 minus 15 gives us a negative 16. So our vertex is going to give us 1, negative 16. So now we found the vertex, we found our x-intercepts, and we found our y-intercept. And now for the last page, we're going to evaluate this quadratic as if x was equal to 2. So we're going to just substitute 2 in here just like we would if we were doing the vertex formula and found our x and needed our y. So we're just going to substitute everywhere there's an x, you put a 2. 2 squared minus 2 times 2 minus 15. And then simplifying, 2 squared is 4 minus 4 minus 15, and 4 minus 4 going left to right is 0. 0 minus 15 is going to be a negative 15. So f of 2 is going to be equal to a negative 15. Evaluating this one, same way. Substituting 5 in everywhere there's an x. Negative 2 times 5 squared plus 5 times 5 minus 1. I'm going to square the 5 first. Negative 2 times 25 plus 5 times 5 is 25 minus 1. One last simplification. Negative 2 times 25 is going to give us a negative 50 plus 25 minus 1. Negative 50 plus 25 is going to give us a negative 25. Minus 1 would give us a negative 26. So f of 5 for that function is equal to a negative 26. And now for the rest of them, we're going to completely factor. This one you can do by looking and factoring it out. This is something you probably haven't seen or haven't seen for a while. Notice there's no b component, so we would want to find a common factor. 3 can go into both of those. There's no a there. So all we're really going to do is factor out a 3. So divide everything by a 3. We take 3a squared minus 15, divide that by 3, divide this by 3, and pulling out the 3 would give us left with a squared minus 5. Going back up to this one again, the c is positive, so we want to ask ourselves, what are two factors of 25 that add to 10? Again, it doesn't matter that that's negative, they're going to add to 10. Well, that's going to be 5 and 5. So we're going to come in here, C and C, and 5 times 5 is 25, and 5 plus 5 is 10. And since the middle term is negative, remember when the C is positive, both those terms have to be the same sign. So we got C minus 5 times C minus 5, which could also be written as C minus 5 squared. Coming down to this one. Now we have an S instead of an X. We're looking for two factors of 84 that have a difference. Why a difference? Because the C is negative. So we're looking at factors of 84 that have a difference of 5. So when we list out the factors of 84, if you list them all out, you can use a calculator to do that. You can come up with 7 times 12. 7 times 12 is 84, and 12 minus 7 is 5. So we come in here and we set up our factors. And we know we have a 7 and we know we have a 12. Well, how do we know which one is negative? We look to the middle term and we give it to the one furthest from 0, which is the 12. So it becomes S minus 12. Let me write that a little bit better. Times S plus 7. Okay, to factor this one completely, notice that there's a negative here. We're gonna take a negative 1 out. We can't factor anything else out. There's nothing else bigger here or common that we can pull it out other than a negative 1. So we're going to take a negative 1, and that reverses every sign in here. So it's going to be 4x squared minus 4x minus 12. So now ignoring this, we're just going to look at this part and say, what are factors of 12? Again, we have a negative c, factors of 12 that have a difference of 4. Factors of 12 that have a difference of 4. So if we list all our factors out, we can come up with 6 and 2. 6 times 2 is 12, and 6 minus 2 is 4. So those are our factors, and we can't forget our negative 1 out here. Put an x and an x, and a 6 and a 2. It doesn't matter which order these are, but we know that the largest number, or the number furthest from 0, has to have the negative sign. So now we have those two. X plus 2 times x minus 6. And we've got one last one to factor completely. And you can use the quadratic formula for this if you need to solve for it, but we're just going to find the factors. So this is going to be where a is greater than a 1. And again, playing around with the factors, we're looking for factors of 5. It's a good thing that 5 is prime, so we know that the second one is going to be a 5 and a 1. The middle term is going to completely disappear, so we're going to play with the factors of 6, which are 2 and 3, or 1 and 6, and put them in different positions to try and figure out what's going to work. Well, if we understand that if we put the 6 with the 5, because 6 times 1 is 6 and 5 times 1 is 5, then 6 minus 5 is going to give us a middle term here. So I'm going to go ahead and do that. Let's put a 6x here and x here. And then I realized that my negative has to go with my 6. Well, this is interesting because I have to put the negative over here so that when I multiply this out, and you can see here in a second, I'm going to go ahead and pause it and multiply this out. And you can actually see that it becomes that negative x. So, and that's it, and that's page 3. Again, if you have any questions or you want to go back and review this, it's a lot of it has to do with factoring and the quadratics.